The first finalist in the Meeting the Challenge of the Difficult Job Heavy Engineering category is Monterey Mechanical. For their project, Southeast Water Pollution Control Plant primary and secondary clarifier upgrades in San Francisco. The City and County of San Francisco contracted with Monterey Mechanical to perform extensive upgrades to its aging Southeast Water Pollution Control Plant. Originally constructed in 1952, the plant required an overhaul of its mechanical, structural, and electrical components at the primary and secondary sedimentation tanks to address operational reliability and compliance for liquid treatment. The $25.8 million project was inherently challenging due to extremely restrictive times that systems could be shut down during the 4-month dry season, June through September, and the 8-month wet season, October through May. Layered on the restrictive scheduling and technical complexities were a number of unexpected issues that arose after the start of construction, any one of which could have derailed the project. The contractor, owner, and key subcontractors took a highly collaborative, proactive approach, partnering to resolve both technical and scheduling issues on the job. The project team came up with numerous engineering solutions throughout construction. For example, faced with constructing a new motor control center in the exact location as the existing one without shutting down the plant, Monterey Mechanical proposed mounting the new control center against the existing one. This enabled replacement of all equipment on time and without plant interruptions. To fulfill the contract requirements of replacing the compressed air system while still keeping it online 24/7, the team built a temporary bypass system. This allowed installation of the new instrument air system without interrupting plant operations. Finally, to keep the channel online 24/7, the city had allotted just 8 hours for extensive repairs. Monterey Mechanical proposed installing a bulkhead that allowed it to take only a portion of the channel offline for more than 10 weeks to perform the needed repair. Employing these and other solutions, Monterey Mechanical delivered a project of the highest quality, on schedule, and $2.25 million under the project budget.
The next finalist in the Meeting the Challenge of the Difficult Job Heavy Engineering category is OHL North America Incorporated for their project Owens Lake Dust Mitigation Phase 9 and 10 in Lone Pine. When OHL North America took on the Owens Lake Dust Mitigation Phase 9 and 10 project, it seemed simple enough. The contractor was tasked with developing several dust control areas using locally sourced gravel cover, regional vegetation, and sustainable shallow flooding on a 3.6 square mile portion of a dry lake bed. The project continued the ongoing mitigation effort to combat the dust storms that have plagued the region for decades. However, executing the project was more complex than it first seemed, and presented the OHL team with a string of challenges. They responded with innovative solutions that helped the job finish on time and on budget. From the outset, several issues had the potential to make or break the project. The first was the lake bed, featuring a saturated shallow water table and very soft, unstable soils. The ground composition hampered movement of rubber-tired rock slingers that other contractors had attempted to deploy. Alternate approaches would have jeopardized the aggressive project schedule. OHL partnered with a major vendor to develop a new low-ground pressure rock slinger equipped with a rubber track chassis that stopped equipment from sinking in the soft soil. 4 modified rock slingers enabled OHL to move nearly 800,000 tons of rock to form a 2-inch thick ground layer over a 78 million square foot surface area. Another OHL designed innovation was the pipe boot. Because soft soil prevented the crews from digging standard pipe trenches, this invention allowed the team to simultaneously place 3.7 miles of pipe and bedding sand around it. The device assisted the team with nearly 45 miles of pipe installation on the job. OHL contended with various other challenges, ranging from extreme weather and the remote location to temporary disruptions caused by the area being a migratory stopover site for shorebirds and waterfowl. A major scope expansion late in the project added construction of 3 warehouses and a welding shop, and brought the final contract value to $239 million. Even so, OHL successfully completed the job as planned.
The next finalist in the Meeting the Challenge of the Difficult Job Heavy Engineering category is SHIMMICK Construction for their project, Trans-Bay Bus Ramps Project in San Francisco. The $56 million Trans-Bay Bus Ramps Project is one element of the visionary Trans-Bay Transit Center. It included construction of a series of freeway on-ramps and bridges throughout the heart of San Francisco's busy financial district. The project connects the I-80 freeway and the Bay Bridge to the new Trans-Bay Transit Center building, spanning 6 blocks and 5 of the busiest streets in San Francisco. The location and nature of the project presented several significant challenges for contractor SHIMMICK Construction. Very limited staging areas meant innovative and detailed plans were required to perform all aspects of the work. False work installation and removal over city streets was performed during night and weekend street and sidewalk closures, each scheduled 3 to 4 weeks in advance to allow time for permitting and various coordination efforts. As the bridge false work was installed and the bridge footprint occupied, access and staging areas became extremely limited. The majority of the bridge project was surrounded by either buildings within 2 feet in several locations, existing bridges, or city streets. The complicated and unique nature of the cable stay bridge construction required an extensive engineering plan that detailed a 14-stage erection sequence and allowed for the safe construction of the bridge. False work for the cable stay bridge section was installed over the top of the partially constructed Trans-Bay Terminal building. To allow for concurrent bridge and building work, the team designed a unique false work system. Most of this high-hazard work was performed during off hours. Construction of the cable stay bridge pylon was also challenging. SHIMMICK and its subcontractor proposed an alternative saddle system not used in the U.S. before, which delivered significant cost and schedule savings. SHIMMICK Construction overcame these and many other challenges to successfully complete this signature project through teamwork, planning, and engineering. Once in service in late 2018, the bus ramp project is expected to accommodate over 100 buses each hour.
The last finalist in the Meeting the Challenge of the Difficult Job Heavy Engineering category is Syblon Reid for their project Oroville Dam Spillway Emergency Response in Oroville. In February of 2017, widespread rainfall in Northern California caused operators at Oroville Dam to begin making releases down the main spillway. But they soon observed damage to the middle portion of the Lake Oroville main spillway. The owner asked Syblon Reid to serve as a prime contractor for the emergency response and stabilization work. Within 2 hours, staff were on site to begin the 24/7 work needed to respond to this crisis. As the prime contractor, Syblon Reid both self-performed and orchestrated the massive construction response efforts involving multiple subs and suppliers. Work involved helicopter and marine construction services, drilling, dredging operations, rock placement, and concrete pumping. The initial tasks included establishing and maintaining control of the existing main spillway gates, clearing trees below the emergency spillway in anticipation of it overtopping for the first time ever, and implementing debris removal operations below the main spillway and at the downstream diversion dam to prevent flooding of the Hyatt power plant. Once the flows over the emergency spillway ceased, the project scope escalated to address many other tasks. The increased flows over the main spillway and the ensuing damage to the chute and erosion of the hillside caused the water level at the Hyatt power plant river outlet to rise rapidly. Syblon Reid operated around the clock, instituting a variety of measures to prevent flooding of the power plant and to keep the generating units dry. The contractor mobilized an arsenal of equipment and vehicles of all types. Over 1.8 million cubic yards of sediment was dredged out of the Feather River to reestablish flows past the bottom of the damaged main spillway and to maintain the Hyatt power plant and support its return to service. An emergency project of this scale and priority was an historical undertaking for all involved. It was another example of Syblon Reid's dedication to its mission of providing solutions to difficult projects.